Absolutely, buddy. Here's a fresh take on the text with some additional details. Here's a fresh take on the text with some additional details. On Tuesday, October 1st, at around 6 p.m. Eastern Time, the Sun unleashed a powerful X7.1 solar flare. This event marked the second most intense flare of the current solar cycle, Solar Cycle 25, which began in 2019. The flare originated from Sunspot AR3842, located near the solar equator. This X-class flare, the most potent type the Sun can produce, caused a temporary radio blackout over parts of the U.S., particularly affecting the Pacific Ocean region, including Hawaii. The flare's radiation bypassed Earth's magnetosphere, ionizing the upper atmosphere and disrupting radio communications. In addition to the flare, a significant coronal mass ejection (CME) was propelled into space. NASA predicts this CME will collide with Earth on Saturday, October 5th, potentially sparking vibrant aurora displays at lower latitudes than usual. This geomagnetic storm could allow solar particles to penetrate deep into our atmosphere, creating stunning auroras. Earlier this year, in May, the most powerful flare of Solar Cycle 25, an X8.7 magnitude blast, occurred. These solar events are not only spectacular but also remind us of the dynamic and sometimes disruptive nature of our Sun. These solar events are not only spectacular but also remind us of the dynamic and sometimes disruptive nature of our Sun. Feel free to tweak it further if needed. Let me know if there's anything else you'd like to add or change.
Sun released one of the strongest types of solar flares, known as an X-class flare, prompting organizations like the National Oceanic and Atmospheric Administration to sound the alarm on the arrival of a fairly large coronal mass ejection. But you probably didn't even notice because the energy of the storm was harmlessly absorbed by Earth's magnetic field. It was big enough, though, that people living as far south as Iowa could see the aurora borealis, and that doesn't happen often. One of the biggest CMEs to happen in recorded human history was the Carrington event of 1859. Thankfully, we were not as reliant on electricity then, but it was big enough to disrupt the world's entire telegraph system. Telegraph operators reported getting shocked by their devices, and auroras were seen as far south as Cuba. If another Carrington-style event happened today, it'd be a much bigger deal.
So in an extreme case, when you have a very, very large magnetic storm, it can actually take out power and destroy transformers over a large region of the United States, for example. And it's not localized like a tornado or a hurricane or flooding. It is regional, multiple states, like the whole New England area or the South or all of the West Coast, depending on how the power grid is oriented and where the energy is absorbed.
While that sounds really scary, it's astronauts in space that have to be worried about solar flares and the radiation they carry. One solar storm in 1989 caused a massive blackout in Canada and gave the maximum yearly radiation dose to cosmonauts aboard the Mir space station in a matter of hours.
Not only does our Earth's magnetic field protect us, also the atmosphere also absorbs a lot of energy that just never gets down to the surface. So we don't feel a lot of the radiation.
Here's a fresh version of your text with some additional details. The recent solar flare is another indicator that we have likely entered the solar maximum phase, the peak of the Sun's approximately 11-year cycle, which occurs just before its magnetic field completely flips. Initially, scientists predicted that the solar maximum would begin next year and be less active than previous cycles. However, it became clear that the Sun's peak activity would arrive sooner and be more intense than expected, prompting researchers to update their forecasts for the first time in history. 2024 has already been marked by significant solar activity. In May, Earth experienced its most powerful geomagnetic storm in 21 years following a series of coronal mass ejections, CMEs, which potentially triggered the most widespread auroras in 500 years. Additionally, in August, the number of visible sunspots reached a 23-year high.